In this video, we discuss a very important topic in calculus, which is a cycloid. First, we discuss cycloid, then we derive an equation of cycloid, and maybe I will show you animation in a beginning of this lecture. So first we go to the cycloid video animation which has been created in MATLAB, and then we derive cycloid, equation of cycloid. So first you see the video. For example, here we have this animation which is created in MATLAB. You can see the object has started its motion from zero, and there is a fixed point that is moving on the x-axis, and that point actually making a cycloid. This is called cycloid, and it just finishes its one cycle. So let me just go to the derivation of this equation, of this graph. First of all, I need to explain few things. As you have seen in the video, the object has, the point has started its motion from here like this, right? And as it moves along, it covers a distance. This is fixed point P, which was actually moving and making a cycloid like that, something like that, okay? The distance covered by this cycle, this is a wheel actually. This wheel, the distance covered by this wheel is 80, and the radius of the wheel is a, which is denoted over here by a, and the angle it makes after it stopped somewhere, this this is called a cos theta, and this one is a sine theta. Okay, so this is all we have. The center of this wheel is a circle, in fact. Since it covered a distance from origin to this point, it is 80. So we have 80 over here. The height of this center is A, which is over here, the second argument of this point. So that's what we have over here. Now, what will be the component of P when it traveled some distance? The component will be equal to, if we just consider this as a point, for example, some point over here, and this is X, then this is Y. So we want to find out the coordinates. To reach over here, you need some distance from origin to here, and then from here to here, like this. Okay, so this is 80. This one is a cos theta. So that will be equal to AT plus a cos theta, and you can see that the x component is AT plus a cos theta. Similarly, for y-axis, the y-axis contain two things. One is this one, and another is this one. This whole actually makes a point P. For this, we have a y component, which is a, plus this is a, then this is a sine theta according to the law. So that will be a plus a sine theta, and this is y component over here. That's what we have. So x will be equal to, if I derive it, x will be equal to at plus a cos theta in parametric form, and y will be equal to a plus a sine theta. The problem with this equation is it contains two parameters. One is theta, another is t. And we have to remove one of the parameter from here. Now what we see over here, for example, this point, for example, has covered this distance. In fact, it was over here as you saw in the video. Then that move into another point, so on and so forth. I made a small cycle. It should be a little bit bigger. It should start from here, then it goes to like this, and so on. So it reaches over here. As you can see, this is the angle covered by this point P. What is this angle? This angle is the sum of one angle which is 180 and another angle which is actually uh, 90-degree, right? So t plus theta, this t plus theta whole will be equal to t plus theta will be equal to 3 pi by 2. As I explained earlier, this is 180 and this whole angle is 90 and it becomes 270. From here we can calculate theta. Theta will be equal to 3 pi by 2. I'm sorry, since we want to remove theta, so theta will be equal to 3 pi by 2 minus t. Put this value into the equation cos theta. Cos theta cos 3 pi by 2 minus t, which is equal to minus sine t. And sine theta will be equal to sine 3 pi by 2 minus t. As you can see that we have to remove this cos theta and this sine theta. That's why we are taking the value of, we are putting the value of theta over here. So that's equal to minus cos t. We put this value over here for cos theta. This becomes x is equal to at minus a sine t, and y is equal to a minus a cos t. And we can also write x is equal to a t minus sine t, and y is equal to a 1 minus cos t, so on. So this is our final answer, and this is called cycloid, equation of cycloid. Thank you for watching.